Okay. So, hello, and this is Mark once again, and this will be my laboratory exercise number 7. Okay, so I'm gonna fix. Hold on. So, I'm gonna fix the view first. Have no one around to capture the video. Okay, so is this good? Oops. Yeah, I think this will be enough. Okay, so the activity title for today is IP addressing exercises. So I'm gonna read the introduction of this activity. So all of the end devices or computing devices have the Internet Protocol address or IP addresses. So it is the unique identification of all computing devices such as laptops, personal computers, printers, servers, etc. Since the computer understands only 1 hour 0, it is important to know the language of the computer. It it should be converted to language that will understand by humans. It is called the decimal number. Binary number is converted to decimal form. In this exercise, it is very important to know the conversion of decimal or to binary and binary to decimal, or even converting to octal and hexadecimal. Okay, so that is the introduction. I'm gonna go to the procedure. So I print all the pages and customize the size of the font. So for the video, it will be clear. Okay, so number 1, convert the following IP address to binary numbers. Okay, so I'm gonna use this scratch paper to solve this problem. So number 1, letter A problem is, okay, so 201.17.29.4. So we all know that IPv4 is a 32-bit. Okay, so it's a 32-bit, and so each part of this slot is 8 bits. So this one here, it is 8 bits, 8 bits. Okay, and the binary formula is 2 raised to exponent equals y. In solving the decimal value, use this because we are this is base 2. As we know, the IPv4 is base 2. Okay, and then this is the exponent value. Okay, so 8 bits, that is 1, 2, 3, 4, 5, 6, 7, 8. 8 bits. Now I'm gonna use the formula of this. Okay, so 2 raised to 0, because our computer by default they start counting from 0. Okay, so 2 raised to 0. So next is 2 raised to 1. Okay, and then so first 2 raised to 0 is equals to 1. Okay, and then 2 raised to 1 is equals to 2. 2 raised to 2. Next, each time it increases. Okay, so 2 raised to 2, it's 4. And then 2 raised to 3, 8. And then 2 raised to 4, 16. And 2 raised to 5, it's 32. And then 2 raised to 6, that is 64. And then 2 raised to 7, that is 128. So this is the 8 bits value. Okay, so we use this to convert the IP address to binary and vice versa. So we always gonna use this. So it's quite confusing, if you will see, but my method on how to solve the IP address, I use my fingers to solve this or convert the binary value to a decimal form and vice versa. And I use this so I can easily remember these values in my hands. So first I'm gonna use this my finger, as you can see. So check the video. So from my small finger here, I'm gonna write 128. To my next finger, it will be 64, and then 32, and then 16. So next is my next finger will be this, and I'm gonna use my same finger because I can write. So this will be 8, 4, and then 2, 1. So I use this finger to memorize all these values, and so I can easily convert the binary value to decimal and decimal to binary. So what I'm gonna do now is solve for the first octet, this one. Okay, so 201. Okay, by the way, when we are solving binary value, there is only two numbers that will be 1 and 0. So it's like this. If yes, when you say yes, that is equals to 1. If no, that is equals to 0. Okay, and then so let's try to solve this now. I'm gonna write down this first. So 201. So 201. Let me write down the value again to this value again. Okay, so if I can solve this by my finger, I don't need to write anything, and because it is quick to calculate everything by your finger only, and because in subnetting we need to calculate everything really fast. So this is our value again. Here's the thing, 201, that's 128, 201 higher than 128? If yes, that is 1. Okay, that is 1. If yes, then I'm gonna write this here. Okay, then minus. Okay, then will be, so 201 minus 128, it's let's say here 73. Okay, and then okay, next, does 73 higher than 64? So yes, that is 1 again. If yes, we say 1 here. Okay, so we write down the 64 here. Okay, this is 64. Okay, okay, I'm gonna encircle the value from my what do you call this, value of bits. Okay, so 73 minus 64, that is, say 64, 6, 1, 13, so that is 9. Okay, and then 0, so 9. Next, we go to the next value. So does 9 higher than 32? So that is no, because 32 is higher, so we will not gonna use that. So X or 0. Next, does 9 higher than 16? So no, because 16 is higher, so X. Okay, next is, does 9 higher than 8? So yes, because 9 is higher than 8, so I'm gonna write this here, and then note down, circle 8, 8. Now 9 minus 8, that is 1, so we are looking for 1. So this is 1 is, does 1 higher than 4? So no, is 0, X. Next, 2, does 1 higher than 2? So no. Okay, X. And then does 1 higher than 1? Now this time it's equal. When it's equal, that is also equal to 1, or yes, the same. Okay, so that is 1, so I'm gonna write here, and then it's equal to 0, so we're done. So the value of 201 is equal in binary, this one, this will be the value. Okay, so I'm gonna encircle that. I hope you can see. Okay, so that is 1 1 0 0 1 0 0 1. That will be the value of 201 in binary. Next, we go to Z number, this one, so 17. Okay, I think I'm gonna use another scratch paper because I will write it in a big letter, so for video purpose. Okay, so first I'm gonna put this here. Okay, so we are still in letter A question. Okay, so next value is 17 from this side. So 17, so 17, that value of 17 in binary is, I'm gonna write down again the 128, 128. So as you can, I will put down my finger. So 128, 64, 32, 16. Next is this side. So that will be 8, 4, 2, 1. Okay. Next is, so we will gonna solve for 17 for this slot. Okay. Next is 17. That's 17 higher than 128. So of course not. 0 x. Okay. Next is the 17 higher than 16. So no. Also 0. Next, the 17 higher than 32. So no. Also 0. Next. So the 17 higher than 16. Yes. So we will gonna use that. 17 minus 16 equals to 0. 1. And then that's 1 higher than 8. So no. And then 1 higher than 4. No. So x. And then so that's 1 higher than 2. No. So last one is 1. So we will gonna use that because it's equal to this number. Okay. So that is 1 equals to 0. Okay. So the value of 17 in binary is equals to this number. Okay, so that is 0, 0, 0, 1, 0, 0. Where am I? 16, 0, and 1. 1, 2, 3, 4, 5, 6, 7, 8. Yes, this is the value of 17. Okay. This one. Next slot is 29. Okay, so we will gonna solve to this value. Okay, so again 28, gonna write down again our value, bits value. This one 128, 64, 32, 16, 8, 4, 2, 1. Okay, so now I will gonna calculate the 28. So 28, this, okay, so 28, that's 28 higher than 128. So no. And then 28, that's 28 higher than 64. No. That's 28 higher than 32. No. So that's 28 higher than 16. So yes, that is 1. Okay, so 16. Okay, so 28 minus 16, that is equals to 12. Okay, so 12. So that's 12 higher than 8. Yes, so 1 also. We're gonna use that 8. This one. Yeah. Use this and this one here. So 12 minus 8, it's 4. So we need 4. Okay, so that's 4 higher than 4? No, but they are equal, so yes. Okay, so we're gonna use the 4 as well. Okay, so that is 0 now. So once this is equal to 0, so the remaining values in bits will become 0. So this number 2 will become 0, and number 1 will become 0 again in binary. So the value of 28, in binary value of 28 is equals to 0, 0, 0, 1, 1, 1, 0, 0. Okay, so that is the value of 28 in binary. So next number is what do you call this? So this value now, we are in number 4 value. So we're gonna solve for number 4. Okay, I think so for this one here, I'm gonna write again the 128, 64, 32, 16, 8, 4, 2, and 1. As you can see, this is number 4. So in this bits value of this, as you can see, this 4, and it has the same value of 4. So I'll just gonna write it in binary form. So this 128 will become 0, 64 0, and 32 0, and then 16 will become 0, 88 will become 0, and 4, since they are equals, it will be 1, and then the remaining values will become 0 and 0. So this is the value of 4 in binary. Okay, so that's how we solve that is how we solve the question for letter A, number 1, letter A. So first I'm gonna write the answer here. So the value of 201 is equals to 1, 1, 0, 0, 1, then 0, 0, 1. Okay, then I'm gonna put a dot. Next, the 17. What is the value of 17 in binary? So this is the value of 17, that is 0, 0, 0, 1, and then 0, 0, 0, 1. Okay, so it is 17. Next, for 28. Oh, I was mistaken in here. So it was 29. I guess I was mistaken in this part. So 28, I write down the, okay, so sorry for that. So let me just recalculate. This will be 29 because I calculate it was 28, so I'm not gonna edit the video. So I'm gonna write down 29. So yes, so it will be 0, 0, 0, 16, yes, 16 plus 4, yes, 4, 24, 28, then 0, then 1. Okay, so this is wrong. I was mistaken. I was seen that was 29. So this is the value of 29 in binary value. Okay, so 16 plus 8, that is 24. 24 plus 4, 29, and then 20, 28 plus 1, so that's why is the value of 29 here. Okay, so it is 0, 0, 0, then 1, 1, 1, 0, 1. Oh, so I lose my space here, so I'm gonna write it down here if it's okay. So I guess I write too big. So next value will be 4. Okay, so 4, I'm gonna write the value of 4, that is 0, 0, that is 0, 0, 0, 0, 1, 2, 3, 4, 5, 0, and then 1, 0, 0. So this is the value of this IP address here. This is the value of in binary. I mean, this decimal value is this is the binary value of this. So, okay, so this one, this is 101, 201, and then 17, 29, and 4. Okay, so letter B question, 192.168.1.1. So I'm gonna solve again. I'm gonna use another scratch paper. So for letter B, it's the same. Okay, same thing. So 192.168.1.1. So this time I'm gonna solve this more faster, so the video will be not too long. So I'm gonna write the value again, 128, that 64, 32, 16, 8, 4, 2, 1. Okay, so first is 192. Value of this is, okay, so 1, 1, that is 192 already, so 0, 0, 0, 0, 0, 0. So value of 192 is this. So I'm gonna encircle the value of that. Next is 168 equals 2. Okay, so as you can see, I just directly write the value of binary without using brown before, so we can calculate this much quicker. Okay, so 128, I'm just adding up the value if it will become until it become equal here. So you can also use that one, I mean this method. Okay, so 128. Okay, so I'm just gonna write 128 plus 64, that is yes, 1 plus 3, yeah, plus 3, 0, 0, and then 32. There's 160 already, so C 1. Okay, then I need, so this 128 plus 32, it's 160, so I need 8. So I'm gonna put 0 and then 1, and then because I'm gonna use the 8, Okay, so it will become 168. So 128 plus 32, that is 160 plus 8. Okay, so 168. So 0 0 0, because that is the value of this in binary. And next, so next lot is this one, 1 1. So as we know, the value of 1 is in the last part, so the 1 value will be equals to, so no, so that will be 1 on the last part, but I'm gonna write, so 128 is 0, turn off, 64 off or no, and then 32 0, and 16, that is no, because we are looking for 1. Okay, so 0 again, and then 4 0, and then for 2 also 0, then 1 2 3 4 5 6 7 8. So the last part, this will be the value of 1 in binary. Okay, so so same thing in 1. Okay, it is 0 0 0 0 0 0 0 1. Okay, so I'm gonna write down the answer this question. So the first value is 192. So the value of 192 in binary is 1 1, and then 6 0. Okay, 0 2 3 4, 1 2 3 4 5 and 6. So this is the value of 192 in binary. And then 168, the value of 168 in binary is 1 0 1 0 1, and then 0 0 0. So yes, this one is the value of 168 in binary. Next, the next lot is 1. Okay, so that is 1 2 3 4 5 6 7, and then 1. Next, and then last is 1 as well, so 0 0 0 0 0 1 2 3 4 5 6 7 and 1. Okay, so this is the answer for letter B. Next, 172. So that is, it's only 172, so I'm gonna solve for B. Okay, for B, for C, 172, right? 172, that is equals to, I'm gonna write down the values again. So 128, 64, 32, 16, 8, 4, 2, 1. Okay, so 172, I mean 172 is 7 minus 128 is 6, 12, 4. Okay, and then 4. Okay, so we need, okay, we need 44 more, so we use this one. So 1 here, and then for 64, so 44 minus 64, so 64 is higher than 44, so no, we're not gonna use that. And then 44 and 32, so 44 is higher than 32, so yes, we're gonna use that. So 1, 32, okay, so minus, okay, so 44 minus 32, that is 1, 1, so we need 11. So 16 is higher than 11, so I'm not gonna use that. And then 8, so we're gonna use this because 11 is higher than 8. Okay, so 3, so okay, so this is the values that we use: 8, 32, 32, 128, this one. So for 3, we need 3, so we're not gonna use the 4, so 0, x, and then 2, gonna use that, yes, 1, check, then 1, so check as well, it's equal to 1, so equals to 0 now. So this is the value of 172 equals to this binary value. See, okay, so 1, sorry, I'm gonna write now 1, 0, 1, 0, and then 1, 0, 1, 1. Okay, so this is the value of 172. Okay, for this one, since this the other slot is 0, so it will be in binary value, that is 8 zeros in. Okay, so what do I mean by that is 0 equals to 8 pieces of 0, so 1, 2, 3, 4, 5, 6, 7, 8, 8 because 8 bits. Okay, so the rest is 0 as well, so I'm not gonna write this here. I'm gonna write the answer in binary value. So the binary value of 72 is first, so 72, that is 1, 0, 1, 0, 1, 0, 1, 1. Okay, so this is the value of 172. Next is the 0, so value of 0 is 1, 2, 3, 4, 5, 6, 7, 8, 8 bits. So 8, 0, and then the rest is 0 as well, so 1, 2, 3, 4, 5, 6, 7, 8. Okay, the rest is 1, 2, 3, 4, 5, 6, 7, 8. So lose the space. So this is my answer for question number 1 from A to C, ABC. Yeah. Next. Okay, so this time, so question number 2. Convert this 10011000000 to decimal number. Okay, so what I'm gonna do now is convert these values to decimal. So it's just the same thing. This time we will gonna add up all the ones, okay, that is used here, and so the value of these ones is the value in decimal. So I think I'm gonna solve this. I'm not gonna use any scratch paper or